So here I'm putting some iodide onto my arm. It's actually a mixture of I2 and I minus that's illustrated on the latter part of this demonstration. Here I'm spraying some starch on. The triiodide anion goes up into there and it makes this dark purple black color, and then it's oxidized by the vitamin C. So in this particular demo, what we're illustrating is the electronegativity of iodine, which picks up an electron and is reduced from I2 down to 2I minus. And this is done with vitamin C, which is an antioxidant, which means it prevents other compounds from getting oxidized, and in fact will cause those other compounds to get reduced like we see here, or it will act as a reducing agent. In the process, the vitamin C itself gets oxidized. And so one can write a simple balanced equation like I've shown here. But behind the scenes, the reaction's a little bit more complicated than this. The iodine here is actually an aqueous solution between I2, which has the red brownish color, and potassium iodide, or any salt of iodine. And together, the I2 and the I minus come together to form the triiodide anion, which has 22 electrons, valence electrons, or 11 electron pairs. And when you write out the Lewis structure, it looks like this. The central I has a formal negative charge on it. It's a trigonal bipyramid molecular geometry, and as a result, this particular species is linear. And that's important because in the starch test, which is essentially what we're doing when we start and spray starch onto this mixture, the starch is a carbohydrate, it's a polysaccharide, and it adopts this helical structure. And the triiodide anion can fit down into the center of this coil, and I've sketched it here. I just picked a slightly different color so that we could see it stand out. And that linear geometry fits in there. And so when the reaction chemistry happens, this purple-black species then goes ahead and reacts with the vitamin C, like drawn up here, and that vitamin C is oxidized, again, like drawn up here. But the triiodide gets reduced, and so the I2 goes to 2I minus, or overall here 3I minus, and then this can no longer, because it's not linear, fit down into this helical form of the starch, and that leads to loss of the color.